What if our planet Earth is not a unique cosmic fluke? Or is it just one of billions of habitable worlds floating in space? For centuries, humanity looked up at the night sky and asked, "Are we alone?" For generations, every known planet resided right here in our own solar system. But over the last 3 decades, technology unlocked an unprecedented discovery revolution. We confirmed the existence of over 5,000 exoplanets beyond our sun. What we found surpassed even the wild imagination of science fiction. We discovered worlds where it rains liquid iron under dark, stormy skies. We found planets denser than solid diamond, orbiting intense stellar cores. Yet, among these extreme environments lies the ultimate cosmic prize, Earth 2.0. These are rocky worlds orbiting safely within the golden habitable zone. Here, liquid water can pool, and stable atmospheres can endure for eons. How do astrophysicists detect these invisible worlds millions of light years away? Which exoplanets hold the most promising conditions for supporting active life? Today, we embark on an interstellar journey to explore these incredible worlds. Prepare to discover the strange alien landscapes waiting across our vast galaxy. Before we look for twin Earths, we must examine extreme alien environments. Let us journey first to Gliese 436b, a world defying chemical logic. Gliese 436b orbits extremely close to its scorching parent star.
This proximity heats the planet's outer surface to over 800 degrees.
Yet, despite these extreme temperatures, the entire planet is covered in solid ice. How can ice remain solid at hundreds of degrees above boiling point? The planet's massive gravitational core exerts an immense, relentless pressure. This pressure packs water molecules so tightly that hot steam cannot form. Scientists call this exotic state of matter burning ice, or ice-10.
Next, we consider 55 Cancri, a massive, ultra-dense exoplanet. This world is twice the size of Earth, with double its density. It is composed primarily of carbon, compressed under extreme internal pressure. Because of this intense heating and pressure, its interior is pure diamond. Moving further, we find TREE-S2b, the darkest planet ever discovered. TAR-ES2b reflects less than 1% of the light hitting its atmosphere. This makes the giant, mysterious world significantly darker than solid coal. Its deep atmosphere absorbs starlight, radiating a faint, ominous red heat. This thermal glow makes the planet look like a smoldering cosmic ember. These extreme worlds demonstrate the endless diversity of planetary formation physics. They challenge our understanding of what planets can look like. In our solar system, we are accustomed to a single central sun. This single star
provides all the light and warmth for our world.
However, most star systems in our Milky Way are binary systems.
These binary systems consist of two stars orbiting a common center. For years, scientists debated if planets could orbit twin suns stably.
The incredible discovery of Kepler-16b settled that debate once and for all.
Kepler-16b is a cold, gaseous world orbiting a binary star pair.
Its orbital period around both stars takes about 200 days.
If you stood on a moon orbiting this world, you would see double. You would witness two distinct suns rising and setting every single day. Standing on the ground, every object would cast two distinct shadows.
These shadows would point in different directions under the twin suns. As the two stars orbit, daylight intensity changes constantly throughout the day.
Furthermore, astronomers recently discovered Kepler-47, a complete multi-planet system.
This complex system features multiple planets orbiting closely around twin stars.
These circumbinary worlds prove that complex stellar dynamics can host stable planets.
Binary systems expand the potential locations for finding alien life exponentially.
They offer countless new destinations in our search for habitable worlds.
What specific criteria make an exoplanet a genuine candidate for Earth 2.0? The most critical factor is the orbital path, called the habitable zone. Often called the Goldilocks Zone, this region has moderate planetary temperatures.
Here, conditions are neither too hot nor too cold for liquid water.
One of the most promising discoveries is the famous TRAPPIST-1 system. Located 40 light-years away, TRAPPIST-1 is an ultra-cool red dwarf.
This tiny, dim star hosts 7 rocky, Earth-sized planets.
Remarkably, 3 of these planets orbit directly inside the habitable zone. Computer simulations suggest these worlds could host vast global oceans.
They might also possess stable nitrogen atmospheres, much like our own.
Because TRAPPIST-1 is long-lived, these worlds could remain stable for trillions of years.
Another prime candidate is this distant super-Earth, known as our planet's bigger cousin.
Kepler-452b is roughly 6% larger than our home planet.
It orbits a sun-like star at a very similar orbital distance. It receives almost the exact same amount of energy as Earth.
This makes it an incredibly promising target for finding active life.
These worlds represent our best observational targets for upcoming space telescopes.
They are the beacons of hope in a dark, cold universe.
Scientists are eager to peer closer into their mysterious atmospheres. How do astronomers study atmospheres tens of light-years away?
The secret lies in a powerful technique called transit spectroscopy. When an exoplanet passes directly in front of its host star, light filters.
A tiny fraction of starlight passes through the planet's upper atmosphere.
Atmospheric gases absorb specific wavelengths, leaving unique chemical fingerprints. Next-generation space observatories use advanced infrared instruments to analyze these spectra.
Scientists hunt for key biosignatures, like water vapor and oxygen. They also search for traces of ozone, carbon dioxide, and methane. Detecting oxygen and methane together would strongly suggest active biological cycles. Researchers also analyze density to determine if a magnetic shield exists.
We are moving from discovering planets to analyzing their daily weather. Spectroscopy is opening a new window into these distant alien realities. The search for Earth 2.0 is reshaping our place in the cosmos.
From diamond cores to twin suns, exoplanets showcase nature's endless creativity.
Each newly confirmed world brings us closer to answering if we are alone.
Earth is our cradle, but the galaxy is filled with future horizons.
Keep looking up, for the next great discovery is just beginning.